So you're in the right talk if you want to see Reini Urban, the famous guy who was ejected from P5P, talking about cperl, which is this project here. It's a Perl 11 project, which means we want to do Perl 6 features in Perl 5 because we don't really trust in Perl 6 being able to do business with it. So we don't think it will be fast enough in the next 10 years. And you still want to keep working with Perl. I don't care if it's Perl 5 or Perl 6, best is having Perl 6 features in Perl 5. Why? Because it's properly designed, unlike Perl 5, which stopped being designed when Larry left, something like 1998 or so. So there were about 20 years of nothing, and then we came up with this idea to restart Perl 5 development. But it was not our idea, it happened before, it happened in 2002 with this famous mug thrower at the wall. And this happened in 2011, where Wendy and Liz invited core members of both teams for a P5, P6 event. It was a core dev workshop, but as usual, no one of the P5 devs showed up. There are some P5 devs, but nobody works on core. Only me, but I haven't even had a commit bid, and so basically nobody showed up, but all the Perl 6 devs showed up. It was free, so she invited, paid for everything, paid for the flight, paid for the hotel.
In the city of Perl.
In the city of Perl, that's very important. Yeah. That's a city between Luxembourg and Belgium. Somewhere over there.
So it's a frontier between Luxembourg, Germany, and France.
Yeah. It's directly at the corner. It's a very nice city and a very cheap hotel. So what I thought out is how to introduce the threading model of Perl 6 into Perl 5. But it's a lost cause, so basically gave up after this. So these are the crazy guys. He's really crazy if you ever meet him. But why is he so crazy? He's a juggler, fire juggling. He's doing Boy Scouting, and he's a Mormon, and he talks a bit crazy. But he does good stuff. He's the developer of cperl. That's a restricted subset of Perl, like Python, very restricted, and it looks like Perl, but isn't really Perly. But then it's about 200 times faster, because he compiles Perl to C++, YOPS, and data. And then runs everything in C++, transparently via inline CPP. And that's Ingi. He's the other friend, you know him. And the next crucial event for cperl was Orlando, 2013. This little rocket where this talk came up that we eventually will never see an object system in Perl. And on the other hand, we also came to the conclusion that the signatures which were proposed at those times were still much worse than the signatures which were on CPAN. So there was no end in sight, and if you want to improve Perl, or at least do some little features of it, you should start properly. And I think this was the time when Stefan bought the main Perl 7 or Perl 8 and pointed it to Scala. And this is what he did before. And what cperl recommends is, of course, mouse, not moose, because this is at least more modern Perl, not so postmodern as moose. So you could imagine a little mouse in here, because it's 10 times faster and does about the same thing. I think only 2% are missing from moose, what mouse does. But they have a problem, a communication problem, because they're Japanese. But still the best, otherwise we would recommend base fields from 5.6 if it would have been implemented properly. And if it would have done proper syntax, otherwise Perl 6 is pretty good, and so we just go for Perl 6. So the C stands for classes, which is basically types. It got a type system, got proper classes, got compiler support. It's basically the continuation of Perl development, which stopped when Larry left, because what they're doing is porting, they're doing architecture stuff, but they have no idea what they're doing within the VM. They're talking about it, but it's horrible. And it's company friendly. Why? It has the compiler in it, but mostly because of the types, the manager types. They love the types because you don't rely on testing that much. You can see all the errors beforehand. But the type system, of course, is optional. It's basically Perl 6. The content of this talk is those 4 points. Features, bug fixes, security, what's still in work, and policies which are different. I started features. Basically, so I worked on it for maybe like 10 years, but I really started on it when the const keyword or the const attribute came up. When Perl 6 decided to drop parrot, because I was the parrot maintainer and decided to fix the proposed Perl 6 release on Christmas and did the proper threading model, threading subsystem, the threading layout for Perl, for parrot, which is basically lockless threading, so it scales linearly. It's the threading model is much better than a MOA VM. It has more architectures, but internally it was completely broken, similar to the Perl 5 state. So it was written to death by certain kind of steps in the last 5 years. The first release came up in February. I developed it internally for a couple of months. And right now we're at 27.1, so I don't really follow the monthly dev releases. Mostly are 3 or 4. It depends on the features. So every big feature gets a new release. So 5.27.0 was with strict names, and the new one will have the classes and strict hash pairs. Let me explain later. I'm the only full-time Perl 5 core developer. And I get about 10 times more done at P5P for 2 years, so it's this line versus this line. And the problem is P5P because they are breaking so much stuff and doing so much damage, so so they are going more down and going more like this. Features, the best features is of course the signature system, which is properly implemented. It's using parts of Dave Mitchell's unop-aux trick, but of course using a proper ABI, so it's not using the _add hash for the values, just the stack. It's basically a modern Perl. Modern means form follows functions, a form follows function. There could be one more way to do it, or more ways to do it, but usually there's the best way to do it. So modern Perl is the best way to do it. You can have a mob and destroy everything or make it 10 times slower, but usually the default should be fast and using less memory. Initially I wrote it for cPanel, so they had different feature sets than we want to have, so they want to have less memory and more security. So I came up first with the memory stuff, so it uses dramatically less memory because it's written, most of the internal modules which are loaded all the time are written in XS, mostly diner loaders, strict warnings, and so on. So attributes, they're written in XS and using much less memory. Config is, for example, using a perfect hash, which is much better than the Perl hash. Then it's very important is the protection from the policy and the destruction they're coming up with all over the time. So every year there's a new great thing they're inventing. The most important thing is the removal of the lexical underscore, which is very important for matching, for nested loops, and so on. It's also much faster. So they were not able to fix it, so they broke it and removed it. They removed using coding. There was a little bug in it which was trivial to fix. Proper signatures. This syntax here, which was added somewhere with 5.14, is of course nonsense. You can have it, but you don't need to have it. You can use proper syntax. It's professional, so it's not like this immature people over there who are throwing names all the time. And there's no mailing list, there's only a GitHub, and the features are not committed directly to master. So there's a discussion with an issue, and then it's tested, smoked, and then it's when everything smokes fine. After some time, it's merged. Basically, in cperl, 90% of Perl 5 commits are merged, and with Perl 5, 0% of cperl commits are merged. So all the bug fixes I'm showing them are in Perl 5.
That's not true. Your name's in the commit history for the past 2 years.
Yeah, because I'm maintaining. I took over maintenance of most of the modules they are maintaining, because they're not able to maintain the modules, which is the worst historical and exutils constant and VADIS and so on. But all the little modules also. So basically, I took over the whole tool chain and adjusted it to be safe and fast. I don't go with benchmarks. You can see it on the website. The memory is interesting. So this is basically P5 years, and this where cperl then went. This is only the memory improvement of config and dynaloader and so on. So UNICODE is still in pure Perl, which is crazy. That's about 2 gig of memory. And warnings, in this figure, warnings are still pure Perl. So warnings will also be a hash. So I start with, I have, I think, 45, 50 features, and I talk about only a few of them. Mostly new compiler features, which are pretty easy to explain. Rate overflow, count leading zeros, count trailing zeros, prefetch, which is very important because cache management is the most important thing nowadays. And we are using 2 big data in our internal data structures. That's why Perl 5 is so slow. So the idea of array overflow is that the add takes 2 integers, and only if it overflows, it jumps to a section which does the conversion to none. So this is IV, and jump overflow 4, and then here you continue, and the n add is about the same, so it's a floating add and jump overflow. So you see it's only 1 instruction, and then you can compare it to the what is done in Perl. It's about 2 pages here, maybe 400 lines, 500 lines. They recently improved it, which is about 50% slower than mine. This is nice especially for hash tables. So this is about my time I'm using, and they are using about this one. So there's a lot of zeros here. That's what I improved initially. That's the original time for Perl 5 core for the hash split calculation. When do I have to do a hash split? So I spend a lot of time with hashes because hashes is basically the worst inside Perl 5 scalars. But it's still only 50% work done yet, so it's not open addressing yet. It's only chain hashing, but optimized fill weight. So the fill weight is somewhere in here. So this is lower, it's better. So this is faster here, and this is slower. And you see several peaks here of different fill weights and different hash functions and so on. That's great. So I can use with those built-in tools, I can try different fill weights, and you can try also. Then very important for security and so on, all these new compiler features. This is basically possible because I'm using proper makefile. I'm using LD and not CC for linking. So the linker is used to link to an exe, and they are using the CC. So I'm supporting link time optimization, the new Clank link time optimization with thin, or even if it has a little bug in it for some things it's too hard to explain, F-stack check and so on. I have reduced the enums, so basically everything what P5P does, I'm constantly trying to remove. So this was removed with 5.6. Enums internally is much better for debugging. I think they had problems with C++, which were not really a problem. So the type system, this is the most important thing, and usually I do a demo, but I have not enough time for it. Oh, I need a different thing, but I'm good on time. Types is crazy. If you read about in the literature part types, you're getting crazy, but you can look at Perl 6. It's not, the explanation is not so good in Perl 6. The best would be MyPy in Python, or in Ruby there's a typed Ruby. I forgot the name of it. The name is pretty good, and the best I think is PHP 7. PHP 7 has about our type system. They also have a good object system, which is optional, so they have scalars and return types. So basically, we can use types not only in my declaration, so a variable declaration, we can use it also in signatures. And then it's checked basically in all function calls and assignments, but not much else because the type is there to make it faster, not slower. Usually, if you read the literature, if someone introduces a type system, this system gets slower. It gets safer but slower. Ours is safer and faster. And usually the problem is with test-driven development, you don't catch that many bugs because I caught so many bugs with the type system in existing modules because I'm running all of cPen with this one. And then I also came up, so I put some core modules, about 5 to 10 I think, into this. So I took over maintenance of those and modernized it. Modernizing means I put the signatures in here with types, especially VOA or some more. You can look, there are a lot of files which are completely modernized. So basically it makes it 2 times faster because this signature makes every call faster. So the test suite runs not only 20 minutes but 10 minutes. So int checks, usually we are using the types when people mix up the order. If they put a string here and a number here, then the type system will catch that compile time. So this is the same. The only what is done is here is adding this one here, and here it's how it's called. And here are some little tests. Subtest int, so we have an int argument, we print it, and then we call it with a string. That's called, of course, a compile time violation because this only accepts ints, and that's not a multi. If you would have a multi, a generic, then possibly we could have another type, but multis are not implemented yet. So the error message is this one. It's basically the same as Perl 6. But the type system is not really super strict. It allows all the internal promotions. So only in a call it's strict. In assignment sometimes it's strict, but many of the types are inferred. So if you assign a constant, and the constant is a string, it's a string type, but then the type check of the string type is loose because internally Perl could use another op to use it as an integer. So it's not super strict. It's not like Go as a static language. It's basically a hybrid, or you call it gradual typing or optional typing. This is another feature. This is basically to show that an int array, and this is even sized or shaped. Perl 6 calls it shaped, so it only takes 2. And we set it to a string, then it will get an assignment error. Or this one is an out-of-bound error. This is also compile time. So this is not runtime. All those checks are at compile time because the compiler optimizes all the internal accessors. Because if the compiler knows it's typed or if it's shaped, it can use much faster ops for those. It doesn't have to use all the checks which are usually done at runtime. That's the basic trick with types. That's why it's so much faster.
Is that last one a compile time check? Or
yeah, that's a compile time check. Okay. Because this is a constant and this is a constant. If this would be a variable, it would be a runtime check. But then the op would be different. I'm showing the op tree later. That's an unchecked op, and if this would be a variable, it would be a checked op. ALMU or ALM. So basically the benefits of types are you can actually using a modern Perl, so it's faster, safer, and looks like a real language. Compile time safety, it's not super safe, it's not sound, how they call it, but it still catches most of the bugs. And it's 2 times faster with signatures. Shaped errors I showed a little bit. So basically they're compile time checked and optionally typed. They remove the runtime out of bound checks and with native types. So if the compiler decides that we can use all those ops here with unboxed ops, oh god, Perl 6 feature. So we have variants of most of the arithmetic stuff, which is using the values directly from the stack unboxed. We don't use an SV. it's basically the same as PHP does. That's why PHP 7 is 2 times faster now, or 60% faster. So it's only storing the word, not the SV. It's not storing 4 words, it's only storing 1 word. You don't have to do the ref count stuff. Also, all the loops are optimized. So if you have a shaped array in a loop, you can do a lot of optimizations. For example, here's a shaped array. Here it's iterating over the array, and here it doesn't even have to be shaped, because even unshaped array, that's the size of the array, the last element. So then it can't overstep the boundaries, because the counter here, it's never changed. So it's here I use an unchecked ALM, and it's about 10% faster. So that's basically what we timed in a compiler. So in a compiler we can easily try out optimizations and see how much faster it checks the unchecked. And this is the opt3. This variant, you see a little. The loop is also different. It's a lazy IV, and this is wrong. This will go away eventually because nobody needs this end. So the different loop types for different, we have 6 different kinds and only 1 op, and the goal is to do the optimizations in compile time and have faster runtime. And the goal of P5P is put everything into one. So put all the variants into a private bit or into a flag and check this flag at runtime. So they're doing all the branching at runtime, and I'm doing the branching at compile time. And this is with the native types branch, where it does more optimizations. For example, here I have a plus with a constant. So this range here is then int const, because this is a native int, this is a native pad. So this is basically the length, or the array length. Yeah, it's the size of the area, and it's known at compile time, it's 1. So it's 0 to 1 at native. And this one, it's doing the typed ops, which are really super fast. So it's basically 1 assembler op. So access the, which one? Access the index at I, which is, what is this one? And add the 1. So int const, this one, this is unboxed, and this is the unboxed op, and this is the stuff which doesn't even overflow, I think. I'm not sure if we're doing the overflow check here, because this is typed, and a type guarantees no magic and no overflow. So a typed int will never overflow to a num. You have to manually cast it. So you don't have to do all these overflow checks here. Okay, what's my time? I'm good. So this is a little trick. This is very easy to add to the parser, the Perl 6 stuff. The fat comma, that's a bit shorter than the big one. That's a shorter arrow. This looks nice sometimes. So you could use it, but only with cperl. It's incompatible. But cperl is incompatible anyway because it's much more features in it. That's an inequality. Those little features here. Those constant things here, or this one, that's a bit crazy. But mathematics look a little bit better. It's almost Perl 6. It's only the dollar sign. If this could be optional, this would be much better. With methods, it will be. Is this the next slide? Okay. Security. So this is really important because Perl 5 really doesn't care about security. What's wrong here? There are security recommendations on UNICODE, on the UNICODE website, and Perl 5 imports all those rules but deletes the security rules, which is interesting. Here we have different scripts. It looks the same, so it's an identifier, but it looks the same, but it's a different script. So this is a different UNICODE character than this one. That's a Greek one, that's a Cyrillic one. And there's a recommendation, never mix scripts. So everything on UDIF 8, there are several script rules. Don't mix scripts, there are only some exceptions. So you can mix this one with this one or this one with this one. If you start with Greek, you can only continue with Greek, but never switch over to Russian. Or if you start with Russian, you shouldn't over switch to Greek. Or if you start with Japanese, you could use Han, Chinese, because they're using Chinese characters, but don't switch to Indian or something. So no mixed scripts. And this is the error message. And this is compile time. That's a nice one. That's even in the specs. That's a bug in the spec nobody wants to fix. So this is a hidden character here. And the normal Perl, nothing happens. And here we get an Hangul, blah blah blah, Hangul filler. There are two characters which are incorrectly marked, which are in the wrong category. And the Koreans know about this, and the others don't care. But for you it's a problem because it looks like nothing, but in fact it's a different character. So you can't identify the character just by looking at it, because an identifier has to be identifiable. It's the same as in path names in Linux. That's a mess. It's garbage in, garbage out. On the Mac it's a bit better because it's normalized. So they collate different looking characters into one. Here's a practical example with cafe. There are two different E's. This is printing the first one. And here, so there are two different functions. And here's one function. This function overrides this one, even if this is a different character, because I'm normalizing the identifiers. It's the same in Perl 6 or Python does it. I think Rust stayed stupid, so Rust said no, we garbage in, garbage out, and Julia decided also garbage in, garbage out. And the security rules say normalize it. So we get the redefined warning and it's a different result. So this cafe is the same as this cafe. But here in Perl it's the different cafe. And here are the characters. So it's basically a combining mark versus direct diacritic. And there are normalization rules. And then strict names is interesting. That's a strict mode where you can forbid unparsable identifiers to be created with this string syntax. Because this is not the proper start of an identifier, and this is not the, I'm not sure about this one, but I think this is the wrong one. So we got invalid identifier 303. That's the first one. This is the parent and this is the one. So this is a wrong XID start. This is a new strict node. So the trick is to enforce parsable identifiers. Then the problem is that P5P is not even maintain its own modules, not the core, but even not the modules. So store was completely broken. It's super easy to write on a stack a certain value to jump to somewhere and execute foreign code. That's why they're discussing changing over to serial or something. It was easily fixed, and I published to cPan, but the module authors are still playing stupid and saying no, you don't have the permissions to change it. It's P5P is the maintainer. So that's known for some time, for a few years. This is known for a few years. This is completely broken. So if you use it, don't use it on cPan. You can use it in core. This is broken in global destruction and many more stuff with locale. All those models were modernized, so they are fast. They're using signature types. So basically HTML stuff, which is pretty big, so I'm saving a lot of memory. Path tools is nice because I'm having actually string checks. So if you pass in a number to a directory name or a file name, you get a compile time error, and all those big nums. I think I fixed this one, but it's not really needed. And then I put in all the fast modules. So the goal is to have the good modules in core and not the bad ones. So JSON-XS, the problem is the name is taken, and I have to convince Schmott to give me his name. So I'm using the old name, even if cPerl is not using it. Then I have a proper YAML, which is completely rewritten and safe, and then comes faster than normal YAML, and you can actually use it. Strict attribute. Dyno loader is written in C, config, access loader. This is in core, because you have to have a profiler in core. And the proper one, not the bad one. So, and basically the idea is to have a suffix, so the version prints a C, so you can identify it. So that's the cheap check. If it ends with C, it's cPerl. Or the expensive check is a config. And in C it's also similar, it's if def use cPerl. What I was doing is I blocked test 2. Test 2 basically works, but the problem is it's too slow. And I would like to use test2 for the features test2 offers, but I don't like the test2 overrides test simple. So it makes everything slower. It shouldn't it should only make subtests with streaming slower. So and then I started fixing test2, but I didn't have that much time, so I think it's currently only 10% slower, not 50%. So the problem is that not even P5P is able to maintain the models. The problem is also the toolchain is now broken. So model build is broken. Leon came up with this build, which is okay. YAML is completely broken. Inge is not willing to fix YAML. He rather creates a new YAML, 1.3. Moose, oh my god, Scala Utet is broken. MakeMaker is pretty good, but the new maintainers, at least they fixed the Windows bugs recently. Test simple, it's a big problem, especially if you, especially for this test2 bug, and if you put it into lib or inc to support 5.6. Because then it clashes with the cperl version of test2. So the object system, this is probably the most important stuff or the most interesting stuff, because types are a bit crazy. But everybody wants to use fast objects. So before I implemented objects internally, the recommendation was mouse and base fields. Pseudo hashes were good, but the implementation was a bit broken. But still, the idea was good. I'm doing it similar, but a bit better than pseudo hashes. I'm basically taking Perl 6, but not as slow as Perl 6. So the idea is it should look like Perl 6 and behave like mouse. But definitely not what Stefan Little talked about before with the hash, because composition with the hash is completely crazy. It's random composition. I want to have an array, and he should at least use the name of fields hash, but we're using a fields array because the order of fields is important. The compiler and the mob should know in which position the field is. The type system is already there because you can't really implement or try to implement an object system without a type system. It's crazy because types are classes. Then several design bugs were detected, but it's not so easy yet to explain it to them. First I finish my object system to be more complete, and then I explain it to them in more examples. It's basically subtyping is a little bit broken. It's not severe yet, so it's nothing serious. And enums are crazy, and what else? And some design problems. It should be more like Perl 5, not too much Perl 6. So all these double sigils and so on, and not really neat. It doesn't have safe structural typing, unfortunately. No sound types, very weak type inference. So basically, this is how it looks like. Your optional types. Here's a scalar, not a string. Here you have default values. You can easily assign default values to it. A method is a keyword. Method that's only allowed inside a class. Does imports a role. So you have is or does. That's in Perl 6. It looks pretty good. You have optional types. That's a bit crazy. I'm not sure if this works already. That's a multi. Not implemented yet, but pretty easy. It will come in a few months. So this is with another point. After, it's this syntax is not after over here, so it's more like the original thoughts from common list. And so on. What else? That's an optional native, so if you have native here, or if you use it in a native call, which is basically an external call, or this native attribute, or is native, then it's basically a C-struct representation, so it means there are two slots, and this is at offset 0, and this is at offset 8 with 64-bit. So it's not two SVs, it's really two ints. So fast write, fast read. And you can use it in FFI, of course. Because the problem is with all these designs, they have to be implemented with an FFI in mind. So you can't really say, oh, we do FFI as well, it's in the module. It has to be integrated in core. The problem is with attributes. Attributes were broken by design since 25 years or 20 years when they came up. So I generalized and fixed all this stuff. So basically const is valid for everything. You have a const package, const scalar, const area, and so on. So you can put everywhere a const in the declaration. Pure is for functions without side effects. That's not really interesting yet, but you can. That's for caching, for internal compiler optimizations. You have core types. So you can use every core type, which is the int, num, string, as argument in the signature or as function return value. So if you have a function, do I have it somewhere? If I put here a colon int, it would return an int. So in C you would have int key core, or in Go it would be different, or in Perl 6 you have the error or returns, and I have only an attribute because I don't want to come up with too many new keywords. I'm just using the existing ones and don't rock the boat too much. No, the problem is one-time attribute values. So this is a daemon model, which is a complete security risk. It shouldn't be in core because it evals the arguments. If you write a documentation in the attribute and say unlink this, then it will unlink this at compile time. It will just call this function, even if it's an attribute. So basically, I'm using the original idea, which was the idea of attributes when they came up with. Use it for everything. So this is an attribute which is a type. This is a native attribute with an argument, and the arguments are basically the same as the native traits in Perl 6. But trait is a crazy name because that's not really a trait. A trait is a mixing. Okay, so calculate is the name of the library, and this is optional. So this is a crazy block. I'm not sure why they're using this. This is completely optional. So a declaration should end with a semicolon. Perl 6 has the same design bug, which is basically you can't. This one. This is the problem. The lib name. $libname, you want to have an evalt, or you want to have the value of this libname in the attributes during declaration. But the problem is with FFI, it's not as easy as with libraries. FFIs have different naming conventions. So in Cygwin it would be this one. So you want to have some logic somewhere in a library to come up with this. You can do it in the native and search for it, or you can provide the name to it. But the problem is you can't provide the value to it. So it needs to defer the evaluation of the attribute to runtime, not at compile time. And that's what cperl does. So basically it's in core already because this does it. So my var attribute, this attribute is deferred to runtime. All the other attributes are done at compile time. And I check what's here, and if it looks like a function call or it looks like a scalar or something, then it's deferred to runtime. So this is probably the most important stuff. What's wrong? What is fixed in cperl? I don't want to show it. It would be an easy one, but it would completely break the system. Just do this one on 64-bit. It will run for several minutes and then crash or out of memory. What does it say? It kills the memory somehow on Darwin or Linux. This is also a good one. A big hash. So it initializes a hash. That's completely broken because you shouldn't allow values which break your system. It's a DOS. And this is of course fixed in cperl. It's even a compile time error. So that's a new error message. Too many elements. So here are only int 32 or int 64 array elements available. So I restricted the number of maximum array elements because the system should have at least 50% reserve to work. Because if you allocate everything you can reserve, then it runs out of memory. Hash security, that's only hash security theater with P5P. They came up with this random stuff, but the problem is that even with a super slow hash function they are using, it still doesn't improve security that much because you can easily brute force zip hash even that. And I think there are a lot of languages out there which haven't understood it. I think the only good ones are cperl and Java, I think. Maybe there's one more, I forgot. But basically Java found out, and D.G. Bernstein, who wrote cperl, he's not using his crazy hash function in its own model. So he's pretty good, but Linux kernel eventually came up with cperl, so it's 2 times slower, but really safer in the routing and forwarding stack, I think, somewhere. Because the idea is to make a hash table secure is to fix the collision resolution and not the hash function. And even Wikipedia is wrong on it. But at least I could convince Google and some other more brighter guys that they're doing it wrong. And then it's super easy to detect the seed. For example, if you can inject this M variable in some fork or somewhere, it will just happily print it. And then you can easily DOS every system out there. With cperl, it's hidden, or with tainted and so on. So it will not easily display it, but if you can peek into it with, what's the name of this one? Unpack. With unpack you can also find out where the seed is written and then DOS the system. I didn't write the exploit, and I didn't go to CCC to announce it, but eventually, maybe sometime I have to. Silent overlaps, that's a good one. What's this one? It looks like a minus, but it's this tilde one. So tilde is basically -2, so it wraps around. So it's this one, this value here. And what it does is -2 of this one is 0. So a tilde 1 returns this one, which is a bit crazy, and they won't fix it. They won't even admit that it's a bug. Even if they're talking about every 5 years about it. That's a good one. So if you're using this index, you will get 1. I like this for crazy ideas. So it's telling the overlapping, and the cperl, of course, it's throwing an error.
This is rejected as a. This is not a bug. This is intended.
Yeah. So the bug is in the heads of P5P.
Yeah.
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 And this is argued for 20 years.
Yeah.
Yeah. I know they reject it, but normal people would say that's a bug. The problem is the interpretation, and you wouldn't bring them to sanity.
System people say it's a bug. Application people say it's intended.
No, that's not nice. There's no. You can't show me any example where those examples are valid or look like valid code. It's even security.
No, I'm a system guy. I
Yeah.
can't.
But when I started working on these large values, I found those bugs, which are basically everything of those are exploitable security bugs. So everything which is above I32 or U32 on this range. So the hash or area overflows, jump only works of the half of the overlarge areas, so you can't jump it, or it does something else. Hash keys are truncated, they're not converted to SV, you can't iterate of those. So you can insert many, but you can only iterate of half of it. Storeover can't handle it, the old Storeover, my Storeover can handle it.
The hash keys are unsigned, actually.
No, they are signed, they're high. Hash keys are always signed because the first bit is the Unicode flag. But only in the API, internally it's a different flag. But they accept only in I32. That's okay, but the problem is an iteration only accepts this one, but internally they accept more. This is truncated, smart match is broken, regex is broken, repeat is broken. So that's completely broken. Then what I worried about with 16, when they came up with the idea of binary names, but they refused to call it binary names. They announced that it's Unicode support, but Unicode support was L5 5.4. So they lied to you about this new feature and insecurity. So you can now use insecure Unicode names. You can use overlong names, which are silently truncated, because most of those are in the hash. Same for file, keyword, MRO, slash names. And symbol table nonsense, which was recently announced. That's a feature, it's not a bug. So auto verification is not a feature. In cperl, I will eventually fix it when we switch over to a better symbol table, which is a linear table, not a nested stash table, because symbol table in every normal language is a symbol table, not a nested stash. The taint mode, you can look at Perl sec, that's basically broken, and I just fixed it in one day. Pretty easy, so the paint flag is now reliable. That's very important for Bugzilla because they are constantly having break-ins with this hash key tainting. Lexical Maya is just crazy. They couldn't fix it. I fixed it in 2 days, I think. This one is super crazy, so this is allowed again. And it's super easy to maintain. He said, no, I can't maintain it like this. The cow system is completely broken. You can't really call it a cow. Basically, you have two those kind of systems. You have copy on write or copy on row. This is very important for threads or forking and so on, because the kernel does it. In the compiler, we're using it because in the compiler, you can even allow write or row. Row means the segment is writable, but you can't extend it. And copy on write means even the segment is read-only, so it's super easy to, for the VMMs, for the virtual memory system, just to page out a page, DLL, UNICODE table, for example, and then page it in back, but you don't have to restore it for 10 times faster. And the cow system with V5P is super crazy. They added the cow flag to the value. So they changed the value when, which should be read-only. And it's all completely unmaintainable, so the way how they've written it, I tried it twice now to fix it, and it still doesn't work properly in the proper cow system. And the worst is they are actively saying they are trying to fix it, so it will get even worse. This is crazy. The double read-only system and the original bug that came up with the double read-only system is still broken. It was super easy to fix. How much time do I have? Oh, I'm super in time. So, the problem is they are to-do list. So what they're not saying, or they have the idea to change the stack to being ref counted, which is completely crazy. They should go to jail for this. The hash table rewrite via vtables is completely crazy, so it's even slower, not faster. And the reason they want to have perfect hashes in core, which is a super stupid idea, via vtables, it's very easy to do otherwise, like I showed you with the config. I didn't show it, but you can look it up with config access. They want to rewrite cow, which is super crazy. Maybe they came up with something good because the context stuff was pretty good. So the context stuff bought us 20%. But for cow, I'm very skeptical for this. I'm super skeptical, and this is just crazy. So this is in work. It's in, but multi doesn't work yet, and I'm not sure about the fields. There's still some problems with field parsing of area and hash fields. And the mob is not done yet. I just started with a simple mob. The FFI did work, but it clashed with the class system. And I extended a little bit, but then in the future you need to add a dependency of libFFI. That's new. So before we had only GDMB and BC2, and then we need libFFI, so we've got an FFI core. Native types, that's a bit more work. There are some compiler bugs. Inlining sub, that's basically the most important. That would be about 4 times faster, I would say. You can look up what Perl 6 and what the improvements were in Perl 6 with inlining. Basically, all the small subs don't need to be subs or subcalls because calls are so slow, so that you can just inline. The hash table rewrite, it's crazy. I'm working on this for 2 years, and I abstracted away everything and fixed a lot of things, and 80% of the work is already in, but there's still some work to do, which I'll do later when I have more time.
Can you clarify what you mean by hash table rewrite?
Rewrite the hash tables.
Like how they work?
No, it will be a hash table. It will be just a proper implementation of hash tables. So not chained. It will be open addressing. It will be eventually with threaded. It will be thread safe, but that's in the future. But it will be probably hopscotch or in hood hashing, something of those.
Okay, so you're talking about changing the lookup.
No, lookup, deletion, insert, lookup, delete, exists. And this is basically needed for everything which is with symbols, all the globals using a hash table, and then the next optimization would also be a small hash table. So basically we found out that everything under 100 is better done with linear search. So for the field stuff, for example, it's better to have no hash table. Internally I don't use hash tables in the fields because that's the constant lookup, but for the dynamic lookup, it's still faster to do linear search and not using a hash table because it's using too much memory and too much overhead. But the constant factor is there, and if you have more than 1,000, you have to use a hash table. But for the small stuff, you're using something better. Basically, everyone else did. You can look at Ruby, and Python did it last year, and even PHP, I think, followed. They have one more feature we don't have, so they guarantee insertion order. So they guarantee order of insertion. So they will print out the keys in insertion order. Our scheme is a little bit better because it's really randomized. That's for security reasons. So they have the what they don't have is we properly announced randomization beforehand, so people can't rely on it. But the Ruby guys and the PHP guys, they have to maintain double linked lists to maintain the order, which is crazy. Mini-Perl, we don't really need Mini-Perl because Dynaloader is in core. Dynaloader is written in C. I just had no time yet. It's only for me because I'm building Perl with them. Unexec, that's a nice one. It's basically a compiler. You just dump it. It works, but I didn't enable it because I was not sure what Stallman and the GDPC guys are doing because they are also crazy. So they are announced to destroy this feature. So it works, but the future is unsure. Lazy parsing, that's a nice JavaScript feature. Basically, you only pass the signature and not the body, and only if you call it the first time, you pass the body from the string. And that's a lot of memory saving. The JIT, basically there are two JITs. First, the simple JIT with LLVM, it's basically compiling core to bitcode, and then properly align all those ops in this list. And then do internal optimizations with LLVM, which are super slow. So you have a warm-up mode and then a run mode. So you do it with CJ or something. C for compile only and J for JIT everything. The JIT then is stored in the JIT cache, in the PMC file, and then the next time it will be not so much fast, but at least fast. And the other idea is then to use the usual JIT tricks with types and guards. So keeping two different op lists together and then jump back and forth with stack replacement and so on. So this will be pretty late. But the LLVM JIT already works. There's just a little bit of C++ is needed, and I don't really like C++ to be used there. And the LLVM is also crazy because they're changing their JIT all the time, so they have now the third JIT to maintain. Flat symbol table, this is pretty nice because you only need one hash table for all the symbols. And I've written this 2 years ago, but there's still one bug, so I didn't enable it. Some crazy head scratching issue. And this one I had no time yet, but I did a little one of UNICODE optimization, which made it 8,000 times faster for the normalization stuff. Because basically everything they do in UNICODE internally in core with those inf lists is super crazy. But you should do it in C and not in pure Perl, looking for a reverse hash in those tables because those tables are read-only, and Perl 6 does it properly. They preprocess everything, and encode XS also does it properly. They preprocess all the tables, and just in core you have everything done dynamically. Slow and big. And this already works pretty good. The PCV JIT works, it's about 50% faster than the normal regular expression engine. It got less bugs than the 5.14, but I haven't enabled yet. It's an external module, RE engine PCV2.
But so it's a faster compiler or faster execution?
Overall, whole test suite. Hyperscan would then be also twice as fast, but it's only for simple regex. But for normal substring search, this is by far the best. But this is super crazy technology, and it's only on Intel. It's using the fast Intel instructions, and this works everywhere. this is eventually later. And then about other feature branches you can look up on GitHub. This is interesting because we have to change the development of Perl 5 to have a future. It's the technical burden and the management problems, the policies. So we rather prefer the practices which were proven in Perl 6 and Parrot. It came up in Parrot, but then Perl 6 took it over. And then, what's his name, Chromatic bombarded P5P for several years, about 10 years ago, with blog posts to change their policies, and they eventually did. And then came up to yearly releases and other stuff, but it didn't disband the mailing list yet. The problem is the toxic mailing list porters, which should be only doing the porting and not language development, and then split up a language development list, which is in Perl 6. But you can't get rid of those guys. The rebase policy is different, so it's basically there are scripts to constantly rebase, so all the branches are constantly up to date, so nothing falls out. There's no, what do you call it? In Parrot it was usually, how did we call it? Oh, we can't work on this branch anymore because it's too old. Too much happened. And with Git it's so super easy, and Git and where it's called? RE. So you have rules for rebasing rebase conflicts. So there's a database of rebase conflicts, and with those it's super easy to keep those 100 branches up to date. You just use it also. It's only Google is using it, and I'm using it. Yeah, I got the idea from Google. And the problem is the tragedy of the comments, because you've got a mailing list which is not able to vote on backwards or other stuff. It just keeps it, nothing will happen. For example, the ink security fix, I did it in the first cperl release 2 years ago. The ink stuff, it was super easy. They needed 2 years to fix it. And the code of conduct was, of course, the best. RGPS, so they're constantly violating their own code of conduct. They're calling everyone else some names, and I'm doing technical criticism, and they called me a violator. And also they promote bad behavior, because that's how I was booted, because Ricardo favored breaking a module when I complained that someone took over a module and broke the API. So he said, oh, we need to get rid of this guy because he complained about someone who was violating it. And at Yapsi, that's the best, but they deleted all those talks when the usual pumpkins or Red Observer talks were calling out people names. And there was never any violation. So we got a lot of time for questions, and I'm pretty sure I know what questions you will ask. But you can try.
You mentioned LTO for CLAN.
Yeah,
I think since GCC 5 and reasonable state-of-the-art mini-utils, you have LTO in GCC 2.
So I repeated for camera. So you mentioned LTO for limit time optimizations of GCC 5. And what was the second part?
Recent mini-utils.
Albino, yeah. Yeah, you need to
too.
Yeah. So basically the configure, the problem is our configure stuff. It's old and it was pre-autoconf. So we can't use those rules. So I had to extend all those stuff manually. But the most important thing was to use the proper make rules. So using a proper make system. You also need it for cross systems. So if you're using CC, not LD, not CC for linking and so on. And using proper LD flags or CC LD flags, so all those problems which came up from HP UX, but which were easy to fix. So basically, if it works, it will be used, but you have to put it into C flags. LD flags are then taken over automatically, by the program. And if you just do GCC 7 or 6 or 5, I'm not sure if I add it automatically. I'm adding automatically a lot of good stuff. I'm not sure what, I have to look up. So LTO is basically the old slow LTO, the LTO with a number. So it's using how much threads. LTO is 4. That's what I'm using at GCC, and with Clang I'm using LTO thin. But this is a bit buggy with certain exports, because if you inline something and also want to export it, they don't keep a copy of it. So you can't use it in an external module because they inline it the way. So Clang is not really that good and also not that fast, but they came up with the ideas at first, and then GCC takes it.
Yeah.
So, but the more important stuff is the CFI and stack check, because that's actually security better.
Yes, of course.
Yeah. That's basically a better version of stack protector.
I'm not sure. I do not remember, but you mentioned a lot of critical Perl 5 bugs. So what I stumbled over the last weeks was when you have an X sub and you pass an array to the X sub, and the prototype has to push it on the stack. The array can be, of course, 65-bit sized, but the stack is only 32-bit sized.
Really?
Yep.
Interesting.
That's a bit, well, annoying sometimes, depends on the size of the array.
Okay, my policy is different. I don't allow arrays which are 64-bit, I only allow half of it. So 50% before
62 is, well,
or 63 is allowed. So.
Yeah, 63 is even bigger than 32.
So that's a bug which should be fixed to allow 63-bit.
Yeah, maybe, or what I'm much more interested in is to return an array instead of stack.
As well.
Yeah, but I don't want to dereference it. I want to have the natural...
But you know what it does? It fills the stack. That's crazy, because eventually I want to get rid of the stack on the heap, because that's 50 times slower to put the stack on the heap. That's crazy idea. That's a design bug by Larry. Larry only did two crazy mistakes.
I can explain you later where this issue comes from.
And the stack should be kept small. So normally the stack size is 8K. So 63-bit is way too much.
That's why, yeah.
So maybe that's why. So you should really put super large arrays on the stack. You can reference.
Depends on calling convention. You sometimes don't have a choice.
Oh, yeah.
That's why it would be more reasonable when you can return an AV.
Now the problem is you copy it. You shouldn't copy such a huge array, because it's double space and then it's broken.
Precisely. I don't want to copy. I have to keep it in the array during the X sub, because of putting mortal copies on the stack will delete. Once do you call back into Perl? Okay. So you have to keep the array either, and finally you have to copy it, and then it's too small. That's stupid. Having a reasonable...
there should be an error.
Having a reasonable signature to return an AV as a list, so that you can assign it into a list.
I'm not happy about this idea. So you should either do a ref or fail properly.
Yeah,
it's too large.
Why you
too many elements, or list too large.
The ref is not possible because of the API is as it is. You can't change the existing API.
He wants to have an empty ref on the call.
Yeah.
And he wants to put everything on the list, a return list. And that's the problem, is because then he has to copy, because there's an area on the heap. And then for passing the result value to the calling function, he has to put it on the stack. But the stack is not meant for such
things. Sounds like a silly API if the API can't.
Well, but it is like it is, and it's like that for 15 years. Long before I entered maintaining this and stuff.
And the normal solution would be a proper error message. Not allow such large lists, because then you have got a DOS attack.
Ideally, you allow
even 63-bit is too much, because just to store all the SVs attached to that array is more than the memory you would have access to.
But 4 times the size, so because you copy everything.
It's
61-bit.
Well, it's silly to copy that stuff. I know.
I'm not sure what Perl 6 stands. Because I think Perl 6 also tries to use the heap, and then
Perl 6 is going to pass the ref.
No,
and auto deref it.
Perl 6 finally does not have X subs.
Different question.
Problem solved.
I think Langenthal should start now.
Yeah, that's why.
Still with them.
Really? Shit.
No, soon, yeah.
5 minutes.
Yeah, 5 minutes, yeah.